Hello, I like breadboards. I don't quite build entire computers on them like certain people do, but they come in handy for a quick prototype build or for testing unusual ICs. You had seen my E&L Industries system in previous videos. They call it a Digi Designer. It's quite convenient with its integrated power supply, debounced switches, LED indicator, plus a handy dandy clock generator. It even sprouted an extension with 7 segment indicators in a previous episode. But imagine my surprise when I found this bad boy on eBay. What? Quad breadboard, 3 adjustable power supplies, 14 switches and 12 indicators, a full function generator with sine, triangle, square and variable pulses to a megahertz? I'm not sure why you designed such a thing in the first place, but I definitely had to have it. Hold on to your breadboards, Ben Eater, here I come. So this is my latest prototype thingy. It's the monster of prototype boards from was just looking to Ken from eBay. And it has a function generator, not just a clock, a function, has sine, square, triangle. It has an extra pulse generator, 3 supply voltages, all adjustable, 0 to 10 volts 2 amp, 5 to 30 volts 0.2 amps.
And are they bipolar?
They're not bipolar, but they are intended to be one a plus supply and one a minus supply. You just have to hook them up the correct way. And 2 meters, you see the volts and the amps. And oh, that isn't working. 10 inputs with 4 more push buttons, so it's like 14 inputs. And 12 LEDs. If they are LEDs or lights, whatever they are, which I know from the other one they have a little amplifier behind, so they're actually high impedance things. Something where I can plug an HP card thing, and then it's been somewhat broken in transport, but we'll repair that. So there's the fuse. Yes, it looks like we hit the jackpot and got the absolute top of the line Elite 2. Which would have cost you a whopping $1,300 in 1971, which Google tells me would be equivalent to $9,024.50 today. We are living the life. And it's the... Ooh. Broken.
And the screw just broke.
The screw broke.
That's not supposed to happen.
I see it's... This one broke too. Something happened to them. They were pre-broken. Ta-da! Wow! That was much nicer than I expected. It has
that's quite a lot of stuff.
A few friendly spiders. Okay, let me
check out those capacitors.
Yeah. A whole bunch of caps that could be bad. Here's my function generator on this side. It's a complicated affair. Oh, look at all these ICs in this thing.
Well, that's kind of wild, the diagonal board.
That's for, this is for, I bet you they are the 7474s for the switches. So you get a clean flip and a clean flop. And here are our transistor for the lamp drivers, but they are actual lamps, oh my goodness. Neon lamps? Are they neon bulbs? Man, if they get broken then... Yes, neon bulbs.
Oh, that's wild.
Wow, so those are the neon bulb drivers. Master, can you figure something more? Because there were 5 caps and only 3 power supplies that we could see.
Yeah, so that was kind of a puzzle to me. Why are there 5 capacitors, 5 power transistors, 5 independent power supply circuits that are almost the same but slightly different, but only the 3 power supplies here? And Mark suggested it might be 2 power supplies for the internal circuitry, and that totally makes sense. So what I've concluded is this power supply with the big rectifier is going to be for your 2 amp power supply. These 2 with small rectifiers are going to be for the 200 milliamp power supplies. And then these two are going to be for plus and minus to the function generator and to drive the lights. And these two have adjustments because these two need to be set at the factory for the internal circuitry. The other three are controlled by the knobs on the panel, so they don't need an adjustment. And then there's two transformers. This transformer powers the interior circuitry, and this transformer powers the user power supplies. So that means
so the user, if he screw up his stuff, it doesn't screw up the rest of the circuit.
You know, if you mess up, put noise into the power supply, short it out, the rest of the circuitry is still going to be powered.
This is way better done and better engineered than I would have expected.
Yeah, so they put a lot of thought into this design.
Yeah. Then we have 1, 2, 3 band switch and one broken one. So the broken one is the one that's really need to change. And then a knob that doesn't turn. Okay, not too bad so far. Okay, we need to replace the fuses and see if this comes up or it just blows up in smoke. I'm gonna get it. There we go. Like this. Okay, jerry rigged 2 new fuse holders. They're not the exact right one, but that will do until I get the right ones. And here the other thing you can see that's wrong, this doesn't work, and it's pretty important to check the voltage. I need to find how to fix that. Actually, I think it spins a bit, so I'm going to do the magic oil trick. Oh, why is it so hard? Oh man. So that thing had a stuck problem for a long while. You can tell that they added this screw ring to hold the dial, that the shaft is completely mangled, and then on the other side it's a construction where everything is connected to everything, which is a little bit scary. Like the strips here connect to the mount of the meters, which connect to are directly connected to the pots, so that the whole thing doesn't remove well unless you remove the whole entire front panel controls. And I need to get access to the shaft to figure out why it's stuck. Okay, I had to remove all sort of things, but then I was able to get the whole mess of spaghetti, and I still can't get it unstuck. But I might be able to remove the wafer and get just the shaft and the holder mechanism. Hooray! I got the stuck part out, so now I have just to figure out what went wrong with this guy. So we know what's wrong. The shaft is just frozen in its bushing, which could be that the shaft is bent, or that there is something between the shaft and the bushing. If it's just frozen with grease, I might be able to get it with night oil. Alright, I'm making some progress. I got it in. I removed the retaining ring, got it in 2 vices. Lots of oil in there, and it's moving. I think I'll be able to remove the shaft, which means it's probably not bent. It's probably just all grease in there. Alright, got it. Classic case of grease having congealed. And so once I cleaned it up, you go here, and voila! And I marked the position of everything before I took it apart, so hopefully I'll be able to put it back together as it was. So this should be like this. I think it's repaired. I retouched everything. Then I have to change those 4 switches. This one, this one, this one, this one. Those two actually are broken in the back, and I have a similar switch, not exactly the same. This is a double pull, double throw. That should work. So let's go. Let's see what's happening back here. Yeah, this one is, those two are destroyed. So this one is broken, and this one also has been semi-broken, and the other one just so much bent, the switch might not work anymore. Okay. Oh my, so much unnecessary mechanical damage. It had been tossed around quite a bit. Fuse holders were smashed, switches shafts completely bent, and they even managed to break the green connector at the right. Poor thing, it got no love at the recycler. Okay, all the switches have been replaced, and actually I can confirm these are 7400 NAND gates arranged in an SR flip-flop. This is what this is. So it's an SR flip-flops, two NAND gates. The output of one is cycled back to the input of the other, and the inputs are to the switch, so this will flip it one way, this will flop it the other way, and there's also a little RC to smooth things out. So this is what I expected. And this surprised me. These are 710 op amps, so it's an op amp plus a transistor driver over here. I guess they went a little bit overboard here. We won't complain about it. And I have in a collection a replacement of the connector here. There we go. It's really almost the exact same thing. Last one in. There we go. Okay. Pile of bad parts out, new parts in. This works. Then question is, will it turn on and give us something? And a 1 and a 2. Yes, I have 5 volts, but it does not agree with me here. So I have something on the dial. Okay, but I have nothing on the output. It says 0 millivolt DC. Okay. Oh, I know why. Because there is standby and operate button. Operate. Well, except it's not exactly what we want. It's 0.3 volts DC. That is not the 5 volts indicated. Then if I move to the other one, oh yes, up to 15 volts. And here I have 15 volts too. Does it show up on the output or not? No. Unhappy with that. And let's try the other supply. And this was more of the same. The third power supply didn't have any voltage at the output either. So not great so far. The meter seemed to indicate a bit of power supply life, but it sure does not make its way to the output. Let's see about the function generator, if we get anything there. So we seem to have nothing. Well, I shouldn't call it nothing. We have a Ripley plus 10 volt on the output, but no generator output really. Zippo 0. Let's see if we have anything on the pulse generator. Aha! We have live. Okay, we have some wobbly. Okay, the width does something. Amplitude does something. It's not at 0. Okay, that does something. There's a little bit of hope, and I can change the width. And the amplitude, my 0 is pretty high. Can I do a one shot? Click. Yeah, I saw it actually. If I get it really slow. Boink. One shot. Okay, so that works. So there's a little bit of hope. It says pulse out, but it seems to be the negative pulse. If I do the other one, well, the negative out doesn't work. Okay. Ah, the negative low works. Except it's not at 0. Right, function generator not great either. Maybe my lights and switches will work? They are a bit complicated though. Okay, on the switches here appear to have a little bit of life. This one works. And the inverse here. Okay, the 7400s are still working. Okay, so those switches do work. Okay. All our switches work. Okay, and that's something. Right, we appear to have one lamp that works. I just had this one going. Okay, that's cool. And the one. This one works. This one works. This one works. So we have our neon bulbs. They are super reliable. Okay. We have 12 working lights. Very, very, very nice. Deep, 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 deep. Alright, very excellent. Okay, so we have to figure out what's wrong with the power supply first. And then what's wrong with the generators later. Alright, a little bit of life in it. Yes, unexpectedly the lights still work. Neon bulbs for the win. But that's about the only thing that works. Let's be honest, this is another eBay disaster. Fortunately, I have Master Ken on the problem and we'll see if he can reverse engineer the very complicated generator with over 40 transistors in it, so we can attempt a full repair. Many, many, many faults await in the next episode. See you then!